Obviously, this is a sine curve, but let's say we have the graph of an unknown function. Now, what do you think if I have a new function, g of x, obtained by enlarging f of x by 2 times along the y-axis? How does it look like? Well, that means the whole graph will be stretched vertically by 2 times, which looks like that. Now, if you look at the position of each point, individually, the y position has become 2 times the original for the same x. For example, this one is 1, it becomes 2 for the same x. This one becomes here, this one becomes here, this one becomes here, etc. And of course, this point and this point and this point, they stay the same because they were originally 0 and now it's still 0. So mathematically, every y position is multiplied by 2. And so when we're enlarging a function to 2 times the original along the y-axis, that means vertically stretched. That means algebraically, g of x will become 2 times the original function, okay? 2 times at the very end. Now let's come back to the original. What if I have the g of x obtained by contracting? Okay, this time is not getting it bigger. I want to make it smaller. Okay, contracting f of x to half the size of the original. So this time along the y-axis, that means vertically, I'm making it smaller vertically. And so this will be the g of x. So when the whole thing shrinks to the middle, if you look at the individual points, each y value becomes 1/2 of the original, right? This is -1 and it becomes -1/2. And this one goes from -1/2 to -1/4. And this stays the same at 0, etc. And so mathematically, every y position is multiplied by 1/2. And so whenever you're contracting a function to 1/2 times the original, okay, make it smaller, along the y-axis, what you need to do is you just need to multiply the function at the end with whatever that number is. For example, f of x equals to 2 to the power of x. So f of x goes through these transformations to get to g of x, and then we want to find the equation of g of x. So firstly, f of x is contracted to 1/8 times the original along the y-axis, and then it's reflected with respect to the y-axis. So first of all, I let graph of h of x be the graph obtained by contracting the graph of f of x to 1/8 times the original along the y-axis. Okay, so this part is what we want to take care of first. Okay, it goes from f of x to h of x. That's the intermediate step. So we start with f of x. Then obviously h of x is just f of x times 1/8. But then we want to simplify it to make it look good. Now we will take care of the second half of it. That is reflecting it with respect to the y-axis. And this is where we go from h of x to g of x. Now, because it's a reflection with respect to the y-axis, that means it's a right-left reflection. And so whatever we had for x now becomes -x. And so g of x is 2 to the power of -x minus 3.